So hello everyone. So I'm Andy Petrella. Happy to be here. Talk about, well, partially about my book, right? So there is a slide about what I do, who I am, right? So I'm going to talk about landscape of data observability. I have 30 minutes. Well, the landscape is gonna be super tiny, right? Otherwise, I need pretty much 15 or 20 hours. Otherwise, I will go through a few things that I believe are highly important when we talk about data observability, and this is why I have subtitled with between the lines of FODO. FODO being the book, right? Because I'm lazy, FODO means Fundamentals of Data Observability, right? And there is a trick with the name that I like. So this works, cool. So this is me. So 20 years of data, of scars and problems and joy sometime. I started as a software engineer in geospatial, so that was pretty nice time, 10 years in there. Then I have 5-year experience in Spark. So in 2010, I was fed up with this private sector, etc. I couldn't talk about what I was doing with data. So I started with Spark in 2010, but the console, the terminal was not super great. So I created the Spark Notebook. Spark Notebook was a pre-Jupyter thing, pre-Databricks. Well, basically because I had a large community using this to deploy data pipelines in production with a notebook, right? So I discovered that I have created a monster, and it created a lot of problems, right? A lot of problems that I have spent the next 5 years until now thinking about what can we do to encounter and to resolve these problems that deploying fast data applications has created, right? So really, nowadays we can deploy really quickly data applications with dbts, with Fivetran, with Airflow, with Spark, with Databricks, with all these things. Actually, we can deploy data application fast as never, right? But actually, there is nothing that was taken into account from the beginning in these practices, which is what I have been thinking about for the last 10 years, therefore. And this is why I created the company named Kensu. The booth is over there, so just swing by the booth to see what we do, because this is exactly implementing everything that I have been saying in these 300 pages. I like to write, so for orally, but I have also a book at Pact. So the last years I have been working on these books, the data governance, data observability, and of course FODO. So a lot about myself, because you could hear that, well, I have suffered a lot from data, right? I have seen people suffering a lot with data because of me, because of my notebook. And actually I have been spending the last years in order to try a solution for the problems that I created. There will be normally these things, if it's connected to the internet, should show. There is no, well, basically there should be, okay, I need to do something. Okay, normally there is a QR code showing up, but because it's not my computer, it doesn't show up. So actually it will not work as I wanted, so I'm sad. So anyway, so normally there was a part. So FODO, what's baked in? For the fan of Lord of the Rings, they will probably recognize the word play that I've done there. So the book is really orchestrated into parts, right? So first there is a long introduction about data observability, because this is a topic that I've been covered a lot in the public blogs, etc. But I think that there are many things that were not covered properly, which are the fundamentals, right? So what really is data observability? But instead we have focused a lot on what can be done with data observability, such as data quality. So because there is a misconception there, I spent a lot of time describing what data observability is, with stories, with examples, right, in order to make sure that we are differentiating data observability for other things. For information, actually, I'm not talking about data observability as a piece of a practice or software that is independent of the others. Data observability, I'm explaining throughout the first chapter that it's part of a bigger thing, which is observability, right? Observability includes the application observability, pipeline observability, infrastructure observability, all these things, right? You don't have a system which is only data observable. You have a system that is observable, right? And this is actually in order to make sure that we're not looking at data observability as a full context. You need to pull it into a system. So I'm describing two things largely: what is data observable, and what is a data observability platform. And there is not a lot of content around these two concepts, right? We're talking about data observability, but actually there are two parts: data observable and data observability platform, right? So basically what happens is that you have a system that has to be data observable, right? The system has to provide information about what it does with the data, right? If the system doesn't do it, it's not data observable, right? It's just a system that does things with the data, right? You can still go into the system and look what the data, how the data is being used, right? You can still do it. Like you can log in the machine, you can look in the logs, you can look in the data, etc. It's not observable. It's just actually you're a surgeon, you have your knife or whatever, and you're opening everything and you look what's going there, right? Right? So actually a system has to be data observable to be able to have the ability to, to be data observable means data observability, right? So it's a capability in a way of a system. However, we're deploying hundreds or thousands of applications nowadays. Pipelines, web services, serving, LLMs, GenAI, whatever we're doing today, right? So we have a lot of them, right? And everything can become data observable, right? I will come back to what is data observable, but that means that you have plenty of systems out there that are saying, hey, I'm doing this, I'm doing that, I'm doing this, I'm doing that, right? So you need something actually to accumulate all this information to make sense of them, right? To understand how the system are playing with each other, how the system are influencing each other, etc. Right? Why? Because why you need a data observability platform? Because actually all these applications, all of them, will have at some point a problem with the data. All of them, right? So you just don't know when, where, how, etc. But you know that it will happen. And you have to know how this problem in these applications with the data will propagate throughout the systems, right? And the platform is actually meant to this, to accumulate all information and retribute this information in a way that can actually anticipate disastrous cases, what I call datastrophes, right? Datastrophe is a catastrophe due to bad data. Let me open the parenthesis. All data in the world are bad to me, all of them. It's just that they are not statistically yet bad enough to be discovered, right? So all databases have bad data, right? It's just that, do you have time to fix all of them, right? Is it worth it, right? Perhaps no. You need to know when it's bad enough to become statistically a problem, right? And that's what data observability is meant for, right? So I'm spending a lot of time here talking about this. Imagine a book, right? So then I'm looking at implementation because it would have been a shame for me to actually disseminate, the best practices and all these IDs and the ideations, right? And then, okay, you guys now have to figure out how to do it. I actually have been spending a lot of time explaining what are the best practices that can be embraced by data platforms engineers, data engineers to actually make the data applications and data platforms observable, right? So there is a lot about this, right? The second part is, well, okay, but I have already data platforms built on open source tools or whatever. What do I do? Then I cover this part. So what you can do with your existing applications and platforms in order to make them data observable, right? And the last part is what I gently called opaque systems that you can turn into legacy system, right? So how do I make opaque systems, so systems that you have no information about, somehow observable? I say somehow because there are some things that you will not be able to do with opaque systems. I'm talking about COBOL system, for instance, right? So what can you do with COBOL systems, right, in order to retrieve a little bit of this capability, which is data observability? So spending a lot of time there. So I have example for Python, for Spark, for Airbyte, for DBT, for Airflow, for all of these in the book, but also there is a GitHub repository where you can pick in, you can see all my code abilities, right? And you can fix them in PRs. Happy to review all of them. So this is about the book, right? So what I'm trying to explain there is not only IDs, it's not only how to say, warm hair, as we say in French, right? But there's also real meat that you can apply from now on in your platform, in application, in your day-to-day. And I want to put some emphasis on data observability. 30 minutes, okay. So data observability is not equal to data quality. Who has this idea that data observability is nothing but just data quality? No one? You can raise your hands. I didn't say. Okay? No one? So just one person? Two, perhaps? Oh, come on. Joe is making fun of me. I hope. So actually, I'm not saying that data observability is equal to data quality, because these are two important components that needs to be implemented in your organization and your platform. It's not like one will do the other. You need both, right? So to take an example, right? So I have a Python code. I assume that everybody can read Python one way or another. I mean, this is why it's so popular. Everybody can read it, right? So basically, I have here a small function, and I'm logging stuff, right? I'm logging the input, X, then I do my computation, and then I log that the input yield this Y value. Okay, I'm just logging, right? Actually, I have applied observability patterns here. I have applied observability practices here. Why? Because my application, when it runs, has the ability to tell me which data has been provided to the function, right? And what the function was doing, and what was the output. So it's speaking to me through logs. It's observable. Does that mean that my application is of good quality? I have used data observability, but is it of good quality? Do you think this function is good? Right? Actually, no. I mean, I'm a mathematician originally, right? So someone does that, actually might have a heart attack, right? So basically what happens here is that I will have problems. So if this thing would have worked, I would have loved to hear your voice, right? But actually, perhaps we can make a hand and raise here. So his logging practice here, part of QA. So logging like this, is it actually a QA process? Quality assurance process. Is it or not? Who says yes? None, right? So it's not the same thing, but actually what happens when I have none provided to X or 0, or actually, oh, by the way, I thought I could call this function with an array. Okay, shit, actually, it will blow out, right? But I will know why it blows out. I will know when, right? In my logs. The application tells me, well, actually, I received X. I don't know if X is good. I just tell you that actually I received X. And afterwards, I have an exception. So, actually, I have a question, therefore. Does logging increase the quality of the code or the results? Somehow. Yes or no? Yes? Only one yes? Right? Actually, if you don't do any logging, right, I'm curious how the code can improve. It's almost impossible, right? I mean, efficiently. Let's be honest, right? So every time you're gonna go to the code and you have to reread again, and you don't know the input, and then you have to look, and then you have to compute, you have to compile, and then you have to build everything in your mind, and then hopefully you have tests, right? And you build this thing. Actually, well, logging, making your data, your applications observable, data observable, right, is actually helping you, everybody, to increase the quality of what we deliver. That's key. With all this information, right, it's a hell to fix anything, to discover and fix them. And then, so that's what I'm saying here, right? So data observability actually highly likely improves data quality. It doesn't mean that they will do it by default, but they will actually improve it, right? And there is a concept that I'm talking in the book, which is actually you can do continuous validation with observability. What is continuous validation, right? Is testing in production. You test that something is not happening or happening in production, right? And people are saying, oh, you don't test data in production, whatever. But this is, for me, test in production. I'm testing that X is actually existing, right? So I'm doing it because I know that if X doesn't exist, then I will have a problem, right? I'm doing it. So I'm not using data examples because actually everything that is true with code, simple code, is true with data. Because this computation, 1 divided by X, when we do data engineering, SQL or whatever, we do this, but at the power of 10. We do this thing, join, and then multiply, and then divide, and then subtract, and then whatever, right? We do these things, but like a million times. And all this function can blow out. And we have no information when, how, and why, right? So, I have a discussion. I would have loved to have the result for this, right? So how often have you hoped that the people who work on the application you're actually looking at now would have actually embraced these practices? So not only you have the code and you have to read this long SQL or this long Spark code, this long Python code or C++ whatsoever, and you have to reverse engineer everything that was done and potentially trying to understand what were the corner cases that were handled with all this if, else, if, as if, right? So actually often perhaps it's hard to answer with a hand raising, but just think about it therefore. I'm so sorry that this doesn't work. Now I'm going to pose 19 data contracts. So who knows about data contracts? Higher. Cool. Woo. Joe. So tell me what the data contracts is. No, just kidding. I'm pausing a little bit because everything is still abstract, I know, right? And in the book I'm taking examples on how this can be implemented, and if you want to see a demo, again, come by the booth, you will see something happening live. So I'm going to talk a little bit about data contract. Contract are like, okay, there is a note here for the extreme people, but it's like types in code, right? So you say what you expect and you say what you're gonna yield, right? So it's a contract in a way. We call it a signature. A signature is like a contract, right? A function as a signature is like a contract, right? This is what it is. And it's good to have data contract. It's good to have type. I'm coming from the Scala world, right? So type is like everything, right? So here, the function, what I'm trying to do is telling me, right, what I should provide and then what I will get. Float returns float, right? However, nothing in Python will enforce this, right? So if you have contract, you need a way to enforce them, right? Otherwise, it's just a lot of time that you have spent on defining things, right? And you are spending time with people, 10 minutes, okay. So and then you have to spend time with people defining these things, right? And at some point, still blow out, and people come back to you and say, but we've spent so long actually defining these contracts, and things like this are still happening. What's going on? They lose faith, and nothing's done anymore. So you need things in place in order to actually enforce them. The thing is that when you enforce something, you close doors, of course, right? So you have to find a good mix between leaving things open and closing things, right? Because a contract means that you don't have the capacity to add a bit of information more that you wanted to deliver to a few people in your company, for instance, right? It's important, right? And therefore people will say, but it takes so long to deliver this poor data. Yeah, but I have contract in place and they are forced. So be careful with this. It's really important. We have to do them carefully, but we have to make sure that these are enforced. The thing is that don't do contract and that's it, right? Contract will not do everything. You still need to have your information. You still need your application to talk about what's going on, right? Because, well, guess what? Actually, people are good at workarounding things, right? So it's not like we have to do one or the other. We have to do everything, We have to do data quality. I have not spoken too much about data quality, but I assume everybody knows what data quality. Basically, you have all these queries that are checking specific things into your data, ensuring it's good, right? This is data quality, and then you check them periodically, right? Data observability is making sure your data applications are speaking on their own and telling you what's going on in order to do everything I just said, right? And then data contracts is also a must-have in order to ensure that people know what they will have to provide and what they will get out, right? So I'm talking a lot about process and human here because they have to be part of the process and the solution. So, and by the way, in Python, it's not hard actually to to work around these things because the float, the contract are not enforced at all, right? So basically you can provide a string, it will not say anything, right? So this is the data contract enforcing. Of course, data contract is not only about types, I know, right? It goes beyond this, but I'm just taking an example, and then you can expand it, you can extrapolate. So what are data observations, right? So I was talking an example about x, one divided by x. Okay, so and just the logging, the input, the output. But actually, if you think about data observation, what do we want the application to talk about? So those are data observations, right? So we want actually the application to talk about metadata. Metadata are not only DF types. You know what DF types in pandas is like the columns, right? Column name, string. Column first name, string. Address, string, right? Age, float, or int, whatever, okay? So this is the schema. You can scan, the application that reads a table, reads a CSV, reads an Excel, right, or whatsoever, or writes these things, right, knows the schema. Come on, they know the schema. They can log the schema, right? But not only actually the metadata means data about data, right? But actually, I'm putting an asterisk here because I like to also receive metadata about the context. What is actually using the data? It's an application. It can be the version of the application, it can be a Python code, it can be Spark, it can be whatever, right? But actually, I want to know what is happening with the data. I want the context. In this case, it's like the version, the Python script which is executed. You log, you're already done your first step into the data observability world just by doing these two things, right? Then you want to log the lineage, right? Or the lineage, whatever you say, right? So actually the lineage is, okay, so I'm using this data and I'm producing this data out, right? Who does that? The applications. It doesn't happen by magic, right? There's an application that reads the data and put it elsewhere, right? So actually the application can log, oh, by the way, I'm reading this and I'm writing that, right? So the lineage, you don't have to extrapolate for whatever, actually this is in the code, right? And then metrics. What happens is that, how often we analytics people or engineers or whatsoever, actually how often do we do this? Do you know the summary? The summary function? You know that function that returns the min, the max, the null values, etc. How often do we do this when we do Python code, or how often do we compute these things when we write SQL code? 100 times probably. But how often do we deploy them? Right? That means that when you do your code, you text this like 100 times, and actually you figure out how the data is, and you assume that from now on the data will always respect what you discover in the summary. And we never deploy it anymore, right? We never check it, right? It's pretty much like in the process function I've told you about, before. I'm checking with 1, I'm checking with 2, I'm checking with 3. Looks good. I deploy. But if 0 is provided, I don't know. So this is why actually I recommend that we log this information in Python, but this can be done outside Python, of course, right? It can be done in whatever you want. Right? It can be even SQL, right? There is a way to do this. And I'm explaining this in the book, by the way. I'm not saying that it exists and you have to find out. I'm explaining how to do it. And finally, because I'm kind of running out of time, right? So I'm just explaining what a data observable system is for me, right? Is this like this sphere of things happening, right? It's transparent. You know exactly what is happening in there without having to jump into the systems and try to look at logs manually or check data manually, etc. So basically, a data observable system is something that is explaining what is being done with the data, It generates information about its behavior across several dimensions. As I said, right? If you know only data observability, you're not good, because actually you will miss a lot of information coming from elsewhere, right? If you know that at some point you have null values, but you don't know which application actually has created these null values, right? You will not be able to fix the null values. What you're gonna do, you're gonna fix the table that you have in front of you. You will do imputation or whatsoever to remove the null values or create fake data, right? But actually, tomorrow you will have all the null values because you have not fixed the root cause, right? You need to have this kind of information in order to understand, okay, this application is the culprit. I need to fix the application first. I need to fix the SQL. I need to fix whatever, right? So, and again, if you want to see, how this can be done in live, right? So without having to implementing everything on your own, like explained in the book, drop by the booth, right? Sami or me will be happy to give a quick demo. I have not much time for QA, and anyway, it doesn't work, right? I don't know if there is a way to have to receive questions. I don't know if there are people actually willing to ask something. But because we're running out of time, perhaps I can leave it that way, and I will take any questions afterwards. By the way, I'm also doing a book signing session at 3, so if you want to drop by, happy to share my awful writing things. And you can reach me out in these 3 fashion, on LinkedIn, my email, and of course on Kansu. Thanks a lot for your attention, and I hope to see you at the book signing or the booth.